My name is Randall, and I'm here to talk with you guys today about service-oriented Flask, obviously. But basically, the talk is really about like writing cool software that scales really well. And so throughout this talk, if you guys have questions or comments or hate mail or whatever, feel free to just tweet it at me, and then once the talk's over, I will read through it. That way, if you have a question, you don't have to remember it, all the way at the end, because that sucks. So we'll do it that way. So like I said, my name's Randall. I'm a developer evangelist at Stormpath, but I'm really just more of a developer. I don't really evangelize that much, so there you go. Before I started working at Stormpath, I also built and founded an API company called OpenCNAM that does billions of API requests. It's a pretty big company. And so everything I'm talking about in this talk, I learned from first-hand experience while building OpenCNAM from the ground up, basically. So that's where all this comes from. I also love Python. I've been doing it since I was a little kid. It was the first programming language I actually loved, really fucking loved. So I'm just really excited to be here. This is also my first big conference talk ever. So excited about that. Thank you. So you're probably wondering why I'm just rambling on about stuff. But the main reason we're here is that scaling software is really hard stuff to do. And there's lots of ways to do it, right? So everyone in this room is a programmer, and most of us can make software do whatever we want, right? If I were to ask you to build a video transcoding service right now, everyone could figure it out. We'd Google it, we'd probably see that this lady right here probably built a library that does it already. So it's not really that hard to make stuff happen. However, scaling stuff is a lot trickier because it's not done that frequently. There's still not a lot of software that makes it simple. And so we basically have to rely on design patterns to accomplish this. So by the end of this talk, what I would really like is for everyone in this room to understand how they can use the service-oriented architecture design pattern to write scalable software. So what I'm going to cover is everything about SOA, what it is, why it's useful, etc. What some rules are for writing SOA code, how to make your services reliable and fast, what the most common problem is that you will for sure bump into, which is really annoying, and then lastly, if we have time, just how to have more fun programming, because I thought it'd be awesome to put that in there. Okay, so first off, what is SOA? So basically, what I do when I start projects most of the time is I create a Git repository, like everyone else in here, and I type for a while, and then eventually I deploy stuff. And with service-oriented architecture, what you do is instead of putting everything in one big project, you put it into a lot of small little projects. Each of those projects has its own Git repo, its own infrastructure, its own API services, just everything. So you have one big site, and you transform it into a bunch of little sites. In this example, let's say we were building a website with an API. If we were to do this in the service-oriented way, we might have a billing API, which handles billing for users, a users API, which is what creates user accounts, edits them, deletes them, etc., an API service for our developers to hit, and then a front end, which renders the registration page, the dashboard, all that sort of stuff. And a really important part about SOA is that each of those services are going to run over the network and use HTTP to talk with each other. So the users service, for instance, might have an API spec that looks like this. So you might say oh, if I post to this endpoint, I'll create a user. If I send a delete request to this other endpoint, I'll delete a user, etc. Another thing is that all these services are very isolated, so each of them have their own unique purpose, and that's probably the most important thing this whole talk. But each service should have its very own unique purpose, and of course its own infrastructure. So when most of us build sites the normal way, our databases, for instance, are shared across all the functionality of our site. So typically, if you have a website that, like YouTube, you would store your user data in a database table, you would store comments in a database table, and then you do joins to access all that data. But with SOA stuff, each of those features would have their own databases, their own caches, their own web servers, everything. So you're probably wondering, if you've never seen this before, why would you want to do this? It sounds like way more work for absolutely no purpose. And that's a great question that you guys didn't ask. So The main reason that a lot of people like it is that each of these services has less scope, right? So if everything has a little purpose, it's way easier to build that. To give you guys an example, I mean, if your boss were to come to you and say, hey, I want you to make a YouTube clone like stat. You have like a week to do it. You would say, oh my God, this is like horrible. There's like so much functionality I have to put in there. It's a lot of work, right? But if you reduce the scope on that and your boss were to come and say, hey, build this video transcoding API, it takes in a video URL and outputs a different video URL, it's a lot simpler because your task is a lot smaller. There's a lot less to worry about. There's less infrastructure. There's less communication. It's just very dumbed down, right? And this is at the service level. It also, if you're in a team, it lets you distribute work really easily. How many of you guys work for a company with other programmers? Everybody, right? Okay. So this happens to me all the time. At work, I will go talk to my friend and I'll be like, hey, Tom, are you working on this part of the code base? And he'll be like, yeah. And then I'll be like, well, I'm not going to work on that part today then. Because if we both work on the same thing, we'll have merge conflicts when we merge stuff together. And it just causes disorganization, right? So we're using communication to solve a problem that does not need to be solved that way. With services, what you can do is you can just break it up to your team and say, hey, you know, Julie, you write the front end, I'll write the user's API, Tom will write the billing API, and we'll just break it up evenly. It's also much easier to think of scaling when you're talking about little services, right? So typically on a big site, scaling is hard because you have many different bottlenecks, right? Depending on what each part of the site is doing, it introduces different overhead and et cetera. When you have a little service, you can think about things a lot easier. Like let's say you're building an API that just stores logs. The bottlenecks for that are going to be pretty simple. It's going to be the amount of disk space you have to store logs and how you're storing it, like what your database server is, how many requests you have. So in that case, you could scale it by just increasing the size of your database, increasing your disk space, et cetera. It's a lot easier to like focus on what the problem actually is that needs to be solved. And lastly, it's much easier to test this stuff. So writing tests is obviously crucial if you're building real software. And when you're testing small APIs, it's a lot easier because you're sending an API request in to test something and checking that the output is what you expect. And I'll get into that more later. So now that we covered sort of the basics, I wanted to talk about the most important rule for SOA apps, which is that you really need to keep things simple. If you're ever working on something and you think, man, this is slightly complicated, you're probably doing something wrong, and you should just stop what you're doing and sort of rethink it. So the first thing is that you should always plan out what services you're going to build. This is like crazy important, and I screw this up constantly. So I have a bad tendency when I start projects to just dive in and write code like immediately. And that's really fun to me. But unfortunately, it almost never works out properly. So I end up having to rewrite stuff over and over again or re-architect things, and it's a huge waste of time. And in service-oriented architecture, this is an even bigger problem because you'll be building services that might not be used or that might be totally useless or might not function the way you need them to. So it's really great before you start coding to plan it out and draw out, which services need to exist for this site to work. And spec out, which API requests should each of these services support. And on that same note, you should always write the docs for each service before you code the service. So not only should you decide what services to have, you should also decide, what is the API spec for each of these services. And secondly, or lastly, I guess, as programmers, we're pretty used to working with APIs, right? Everyone in here, yeah? Okay. So there's two ways to work with an API. You can either send HTTP requests directly, which is okay, or you can write a wrapper around that in Python or whatever you're using to abstract some of that logic. And the truth is that it doesn't matter which one you choose to do, as long as you do it 100% the same everywhere. So my recommendation is that if you're doing this, either make everyone use HTTP requests or make everyone build an API client. So now let's talk about making this stuff reliable, which is a lot easier said than done. But so first off, I'll probably get a lot of hate, but integration tests are way better than unit tests. Like, I feel like unit tests are just a waste of my life because I don't want to get old and like have not finished building my projects, to be honest with you. So only write integration tests. I don't care if you write unit tests or not, but it's just a waste. If you are writing integration tests, the library Flask-Testing is incredibly useful. It wraps the Python standard library's unit test module and has some really nice sort of helpers to allow you to run your service and do some testing and whatnot. Here's just a little code example taken from their docs. But if you Google it, you will find the same thing. So secondly, one of the problems you will like absolutely for sure bump into when writing services and testing them is that if you test a service, you probably need other services running at the same time. So think of it like this. Let's say you're testing this web service that you built that is just rendering the front end of your site. And you want to make sure that if a user signs up on your site and hits, create my account, that their account actually gets created. In a normal application, that's super easy to do because everything's in the same code base. When you are building a service-oriented application, however, you'll have a user's API, which creates those users for you. So in order to successfully test that, you need to spin up that user API and have it running locally. That way you can send off those API requests and make everything work. Now, there's a ton of ways to do this. They vary in complexity by a huge factor. There's Docker, which is a really awesome tool, but very out of scope for this talk. So instead, I'm going to show you guys how to do it the really easy way with the tool called Foreman. So Foreman is a really awesome Ruby tool. It's been around for a long time. A lot of providers use it. And basically, it allows you to define a text file in the root of your project. And you basically just define it like so, above over here. So every line contains a service definition. At the left side, before the colon, is the name of your service. So you could call these things whatever you want. Then at the right side is the command you use to run those services, like the web, like start them up. So in this case, I'm just using the Gunicorn web server, starting each of my projects. And once that's defined, when you run Foreman start, it will boot all those services up at the same time, assign them each a different port, and bam, you're ready to go. So super useful for testing stuff. So next, if you really want to make things reliable, this is something you should always be doing, which is keep your development environment the same as your production environment. And this is sort of kind of common sense-ish, but like I've noticed that not many people do this, and it typically causes issues. So the problem is this. Murphy's Law will happen, especially with software. Like if something can possibly go wrong, it will for sure go wrong on you, no matter what. So, if you're using a Postgres database in production, that means you have to install it on your laptop in order to test things properly. Now for Postgres specifically, I actually run a service which can help you with this if you don't want to install the whole database stuff locally. So there's a service called postgression.com, which I created with a friend a while back. And essentially, you don't need to sign up or anything. You just hit api.postgression.com and you get a Postgres database that you can use for testing or local development or whatever. And the best part is that after an hour, everything in that database just disappears. So you can use it for integration tests or whatever you guys want to do. So next up, and again, this is about building reliable services. You're going to want to always auto-deploy your code. No matter what anybody else tells you in the whole world, they're wrong. Because basically, if you don't deploy your code all the time, it's only going to hurt you because the farther away you are in development and production, the more opportunity for bugs there are. It's just a fact. That's science, man. So just do it, or else bad things will always happen. And lastly, just in case any of you guys are not already familiar with the service Travis CI, it's a really nice service that you can sign up for to do testing for you and deployment if you want. So it's really great for your auto deployment and stuff like that. And their website is travisci.com. So next up, planning for downtime is pretty critical. I can't really go into too many specifics because it's so generic, like talking about this. However, when you have service-oriented architecture and your services rely on each other, like what happens when one service goes down? It really makes a difference to users how you handle this, right? So if you're making HTTP requests to your API service to like create a new user account, for instance, and you don't properly handle exceptions, then if your user API goes down, people are going to see a 500 or whatever your web server is configured to do. And that sucks, dude. That's horrible. So just be aware of that. Try to keep it in mind. And never assume that everything is going to be working. You're also going to want to monitor all of your services. And the way I like to think about this is like this. When you're running a project, a monolithic project where everything's in one big code base, monitoring is obviously something you have to do because you want to know how fast your requests are going, what bottlenecks you have, if something's down or not. And if you have a bunch of little services, the amount of stuff you have to monitor just grew by like a huge factor. So monitoring becomes even more important. And there's tons of different tools to do this with. If you're looking for an easy answer, I think New Relic's a really good choice. So newrelic.com, it's a hosted service, but basically they give you a really cool dashboard and they show you, how many requests you have. You can analyze each request, see how long it took to do everything. You can see how long you spent talking to the database, how long you spent talking to your cache, etc. And of course, uptime and downtime and stuff like that. So now let's talk about some of the just more general rules for building SOA applications. So first off, always use HTTPS. If you're building a big application like where everything's in one code base, this isn't so much of an issue because let's say you create a user account. That's happening on your web server. So you're not sending anything over the network except what the user sends to you. That's not the case for service-oriented apps. So let's say your front end receives a guy's username and password and it wants to create a new account. You will send an API request from your front end server to your user API to do that creation. If you're doing that unencrypted, then bad things will most definitely happen because all that information is public. So you should use HTTPS to prevent that. And if you don't want to buy SSL certificates, then startssl.com will give them to you for free. So there you go. Now, handling SSL in Flask is really easy. My good friend Kenneth Wrights, the guy who created requests, also created this library called Flask-SSLify. And basically, you just instantiate it like so, and bam, like everything is encrypted and it works properly, etc. Furthermore, since you're building a lot of APIs, you don't want to have these APIs public, so to speak, right? So let's say that I somehow find your user API on your website, and I send a post request to it and attempt to create a user. If you do not have authentication and authorization on that API, then I will be able to do that, even if it's over HTTPS, obviously. So you really want to, at the bare minimum, password protect your API services. Now, the simplest way to do that in Flask is using the Flask basic auth library. This is how it works. It's the best bang for your buck in terms of time. Basically, you import this guy, you specify some config options like what username and what password are required to access your API, and then bam, like everything just requires it. So secondly, when I was building OpenCNAM, one of the biggest mistakes and regrets I have is supporting every serialization format known to man. So when I started it, I thought, oh man, it would be so cool if all of my APIs supported like YAML, JSON, JSONP, XML, and like everything else. And that became a maintenance nightmare for me. It was a huge, huge time sink because I was doing it for every service, and none of them were ever used except JSON. So my recommendation is don't do that. And lastly, if you cannot deploy each service in a single line of code, then I feel bad for you, because when you're deploying one project, it's not so bad if you have a complicated deployment procedure, right? Like let's say it takes you like 10 minutes to deploy. Oh well. If you have like 10 services and it takes 10 minutes for each one, you are like in for a world of hurt. So I tend to deploy my applications on Heroku because I just push Git code to them and they do everything. But whatever you're doing, try to keep deployment as simple as possible to save yourself time. So now let's talk about speeding stuff up. This is a big topic. A lot of people think that service-oriented applications are slow. The reason they think that is because you have all these API services. They're all running over HTTP. That means every time you access them, you have added network latency and handshakes going on. And that can be slow. So the first thing is that don't worry about optimizing your web server. It's totally pointless. Every web server, for like more or less, is totally sufficient unless you're an enormous company. Second of all, use caching for everything. Like whatever you can cache, like you should cache it. And there's multiple ways to handle caching. I'm going to talk about this and break it down. So on the left here, we have a service, and it has some code, and it has a cache, right? Now let's talk about this in example form for a moment. Let's say you're building a service that transcodes a video, right? A user sends you a video to transcode, you transcode it, and you return the thing you transcoded to the client. That makes total sense, and that's very simple to write. However, transcoding video takes a lot of time. It might take 10 minutes to transcode a video. And so obviously, if you're getting a lot of repeat videos sent to you, you don't want to waste time transcoding the same thing over and over and over again. So what you would do is use a cache. So essentially, the client will send you a request. You will check your cache and say, hey, have I ever done this before? Yes or no? And if the answer is yes, then you skip processing altogether and just return the result to the user. And that's fine and dandy. And again, that will greatly speed up your server-side performance, although it will not necessarily reduce network latency. So for reducing network latency, you have a couple of options. The first option is add a cache on your client as well. And we'll get into that later. The second option, which is slightly more complex but good if you have public-facing APIs, is to use a content delivery network, which is the big CDN thing right there. And I'm sure most of you are familiar with this. However, I thought I would just mention it anyways. But there's two big content delivery networks I'm familiar with. There's Amazon's CloudFront and Fastly.com. And both of them do the same thing. They basically run caches for you all over the world. So the way it works is a client will first talk to this cache that's near them physically, which has a lot less latency. And if the answer is already in there, if it's something that's already been calculated, it will return it directly to the user without ever touching your API service. That's a really awesome feature. If not, the CDN will just forward the API request to your service to process stuff and then return it and cache it. Now, since handling CDN stuff is sort of out of scope for this talk, I did want to briefly mention how to do caching in Flask on your backend, which is ridiculously simple, as you can see. Just use the Flask-Cache library, and it supports all the different backends like Memcache and Redis and whatever else you probably like. And so you just configure it, and then it has a very simple API for caching stuff. So, you know. So now let's talk about scaling services. The most important part of scaling any service ever, doesn't matter what you're doing, is just finding out what the bottleneck is, right? If you have a transcoding service, it's going to eat a lot of CPU. So therefore, you're going to have to scale your CPUs out. If it's something that, if you're running the Pirate Bay, for instance, you're getting a lot of network traffic going on. So I/O is most likely your bottleneck. So you have to know about bottlenecks first. The way I like to handle scaling in almost every case is that I like to just throw money at problems and make them disappear. So if you have a transcoding service, for instance, that's running on one server, and you realize, man, this is taking way too long, there's a huge queue of videos to transcode, the best bang for your buck and time is to just buy a bigger server with a bigger CPU and just use that. That's the easiest solution. That's vertical scaling, which looks like this. You get your server and you just make it like larger, right? So horizontal scaling, and again, I know all of you are familiar with this, I just wanted to cover it anyways. Horizontal scaling is really useful when you want to distribute stuff in a massive scale. So if you have a transcoding service that's transcoding so many videos that you can't buy a CPU big enough, then your next best option is to just duplicate that server, have a bunch of them, put them behind a load balancer, and send different requests to each one. And again, this all makes sense. So next up, one of my favorite things about Flask, and the reason why I built my API company with it, is that it does not bind you to specific tooling, which I think is very important for SOA apps. This is the reason why I think it's far superior to Django in this specific space. When I was building OpenCNAM, what our API company does is it basically gets information about a phone number and returns it to a developer. That's it. So we have a primary key, which is a phone number. When I first built the service, I was using Postgres for this service that I built. And what I did is in Postgres, I had a table, and the primary key was a phone number, and then the rest of the columns were just data about that phone number. Very simple. So when a user made a request, I would talk to Postgres, pull stuff out, and return it. So after I spent some time analyzing the performance of this thing, I realized that no matter how much I tune and optimize stuff, or how big my Postgres server is, there's about a 25 millisecond delay in order to execute a query and return it to me. And that's really good performance, but I thought I could do better. So I looked around and tested a bunch of different tools and stuff. And in the end, I settled on using Amazon's DynamoDB because in the same scenario, it's a big key value store. So you have the phone number as your primary key, values, all the other stuff. In the same scenario, it only took a single millisecond to pull that data out of Dynamo, which is ridiculously, ridiculously fast. So the point of this is that since you're using services and you have the flexibility to not bind yourself to a single tool, why do it? Use the best tool for the job. It's also more fun to learn different stuff. So there you go. Next up is queuing everything is incredibly important, right? So queuing, for those of you who may not be familiar, is basically the process of taking a task that you're trying to do and then just doing it later because you don't need to do it immediately, right? A great example is if you're building a logging service that logs every request a user makes. It would really slow your API down if every time a user visited a web page on your site, you sent a request to this logging service, waited for it to respond, and then rendered the page for the user. That's going to add an extra 200 milliseconds or something like that. So to avoid that latency, what you can do is just put it into a queue and say, hey, at some point in the future, I want you to hit this logging service and tell it that a user visited this page. And in the Python world, there's really two big queuing libraries that you can use. There is Celery, which has been around for a long time, really popular, has a ton of support for different backends and stuff like that. And then there's a less known, littler piece of software called RQ. RQ is really awesome, and it's become my favorite tool over the past year or so. And basically what RQ allows you to do, it uses Redis as a queuing server. And basically it has a really simple Flask integration, which you can see up here. You initialize it, it's very simple. And you can do basically the same stuff you can do with Celery with a couple of exceptions. Excuse me. And it's just way less work. There's a lot less documentation, it's a lot clearer. There's less stuff to worry about configuring. And for the most part, it's not going to matter. And lastly, in terms of speeding stuff up, I've always felt like there's two ways to speed things up, right? There's like actually speeding up your service, and then there's like shortening your development time. And I'm putting this in here sort of just because I feel like a lot of people don't really consider this, but there's tons of API companies nowadays, right? Like there's stuff that does like crazy random things. And so if you can utilize that, I think you should do it. So the less code you have, like the less problems you're going to have normally. So here's just an example. Let's say you're building this site on the left over here, and you've decided, okay, it's going to take me 5 services to make this thing happen. So maybe you decide you need a logging service, a front end, an API, a billing service, and a user service. If you wanted to save yourself some time, you could just replace those components with the services on the right. So for logging, for instance, you could use something like Loggly. It's a service that just stores logs. For billing, you could use something like Stripe, which just handles billing stuff for you. And it will require you to write almost no code. And for users, if you don't want to store your user information, and I'm kind of biased here because I work there, But Stormpath is a really cool company that can help do those things. So now we sort of covered those things. I also wanted to share what was my single greatest problem while I was building OpenCNAM from the ground up, which was user data. The problem with this is that all of your services you build are going to be used for something, right? But some services will be used a lot more than others. And what I found out the hard way is that your user data is relied upon by almost every other service you have. You know, if you want to bill someone, you need the user's information to bill. If you want to log someone into your website, you need the user API. If you want to authenticate developer requests, you also need it. So it's, you know, unevenly distributed. And the main problem with this is logging users into a website in a service-oriented fashion. And this took me forever to figure out because, like, I went through multiple iterations of implementing this, and all of them were just god-awful. So here's the problem. You have your front-end service, which renders web pages, right? Renders a login page, registration page, etc. So let's say a user goes to create an account on your site. So they click the thing, they get a nice little form, they fill it in, and they hit submit. The code goes back to your web server and says, hey, we have this user's data. How do we create the account? So you send an API request to your user API, and you say, all right, create this user. It sends a request back to you, and it's like, okay, the user has been created. So what do you do next? Now, you know that like the way to do this is using sessions, caching some of the data, using cookies properly, which is a whole other discussion. But you don't want to implement that all yourself because that's a really, really, really bad idea. So I want to break this down for you guys. The first thing you need to do, obviously, is build the user API. Now, if you guys are using Flask, which all of you are, I would highly, highly recommend the Flask-Security library, written by a guy, Matt, who's around here somewhere possibly. Anyways, the dude is a totally awesome programmer, and Flask-Security is really great. Works with SQL Alchemy, so you can use Postgres and MySQL to store your user stuff. It's very configurable. It has a lot of different features. You run it yourself, obviously, that's a plus. The only problem is that since you're doing SOA stuff, you want to turn this user thing into an API, right? So you have to build an API around this functionality. So if you go this route, the way things will look is like this. The user submits a form to create an account. You send off a request to your user API, which is backed by Flask-Security. You send it back to the front end. And then in your front end, here's the magical part that like it took me a long time to get working properly, is you're going to want to use the Flask login library. Because what this does is it basically abstracts session support for users specifically. So it has a lot of features that you're going to want and need in order to make this work properly. Unfortunately, I do not have enough time to go through all the code examples needed to make this work, but you can figure it out through their documentation fairly easily. Next up, and again, I'm super biased because I work here, but I maintain all of the Stormpath Python stuff, including the Flask library, and I guarantee you that it's super awesome. And so since Stormpath is an API that stores users and user data, the library is super easy to use. So you don't have to set up databases or anything like that. You just plug it in and stuff works. So lastly, this is my first big conference talk, and I figured that like, since I'm going to do it, I might as well throw in something that I really like at the end, because screw it, why not? So I wanted to throw in a section about having more fun because I am a pretty okay developer, and I have only been programming, or I've been programming since I was a kid, but professionally not so long. But my superpower is having fun while programming, so I thought I would just share some of the things that I like. So I want to be real with you guys. Programming can be like super, super boring if you're not enjoying it. And for me, that means I just want to be doing more programming and less of like everything else that ever existed. So here are my tips. So first off, own your code. What I mean by this, I was talking to some friends about this, and they all disagreed with me. But when you work at a company, one of the things I hate is a lot of people will say, hey, you know, you and some other guy are going to work on the same piece of code. The reasoning is that, you know, if you get hit by a bus, we need someone to take over. I think that's total bullshit. I think it's just a waste. I feel like it sucks the fun out of everything. I like to just do things on my own and learn and like have fun with it. So SOA is a really great excuse to do this at your workplace, first of all. You can tell your boss, hey, you know, it makes way more sense economically. If you just put me in charge of this service, I'll handle everything. So you write the API spec, you learn all the tooling, you have total freedom to do it however you want. And I think that's a huge win. That makes my life way more enjoyable. Also, the biggest tragedy of my lifetime, I feel like, is not releasing code as I write it. Because what happens when I stop releasing code is my life just sucks. Like, I'm working on stuff, it's never shipping. It's like, why am I here wasting my life? I could be on a beach or playing with my dog or seeing a movie or something. So, you know, release your code as you do it. Auto deployment is the best way to do that. So if you work in a company where they don't do that, just like force them to do it or quit. And lastly, I only have 3 tips, so bear with me, just the last one. But whenever you program stuff, just tell people about it. I think it's so much more fun to share your experiences with your friends and your peers and stuff. And I've talked with a lot of people about this, and a lot of people don't do this. They're very quiet, which is fine. I'm actually very introverted, even though I'm giving this talk, using all my energy here. But telling people about what you're doing makes things way more fun, because you get to collaborate with other people, you get to like get a little feedback bounced off, and generally it will just make you happier. So those are my tips. Thank you guys very much for having me. It's been a super pleasure. Thank you. I also just wanted to say I'm a super laid back guy. If any of you guys want to talk or hang out or whatever, that's my phone number. You can text me. That's also my email if you have questions afterwards. And again, thank you. And I will now look through questions and read these guys off if I have any. Actually, let's do that on here since I have no phone reception, of course. Okay, cool. So I have no questions. So if any of you guys have questions, feel free to ask them. Yes?
So if you work on things by yourself, do you just go to a doctor?
Yeah, totally.
People have to come in and like fix the bug or take over your stuff.
So I feel like working by yourself is not an excuse to be lazy. It's more like an excuse to like teach yourself more things and improve your awesome level by a huge amount. So you got to push yourself if you want to have fun at anything, right?
Is it ever like backfiring you?
All the time, constantly. But like that's part of life. You want to like have those experiences. Yes.
So where would you say is sort of like the point of maximum efficiency with this? Like you don't break everything up into a service, right? Like is there a micro optimization black hole where it's just like you really need to keep these things together rather than separating them out?
That's a really great question. And honestly, so I have a lot of experience doing this in my company. And the way I see it is that when you think of your project as a whole, there are certain things that naturally stand out to you that should be separated out. So for instance, like users is something that sort of seems that it can be separated easily. Billing is another thing, you know, sending off reminders like, hey, you're late for payment and whatever. And I feel like just go with your instinct when you're designing it and then stick with that. And as you grow, you might make changes, but you know, if you do your best, it's not really that hard to re-architect things as you're going through. These services are so small, like you can build them in a matter of days. So it's not a huge time investment. Yes?
So for the authentication, Flask-Security, what would you suggest if you have applications that are built on multiple different platforms and you want to be able to use that integrated authentication?
So what you're asking is if you want to use different like applications, different programming languages, probably. Yeah. Yes. So what he's saying is if you're using different languages, you still want to interact with your user's API. The question is, you can actually do that. Like, it won't cause a problem at all. The reason why, Flask-Security is only powering the user API backend. It's exposing no API endpoints. All it's doing is creating users in a database, hashing the passwords, etc. So it's the API you build around it that all of your clients will be using. So if you're writing PHP, you can still send a post request to users.myapp.com to create a user.
Yeah, my question is actually a little bit different.
Okay.
I guess that for what if you have an application
Mm-hmm.
that are working on portions of the site, those are built in different platforms. One's built in PHP and the other is built in Windows ASP.
Yes.
How do you give the user a seamless experience?
Basically, what you're asking about is how to properly pass a user around to different portions of a website that are built with different tools. And that's another really great question. Basically, the way you have to do it if you want to make this clean is to use single sign-on. There's really no way around that. If you need to be passing a user around between services, you have to build a single sign-on to authenticate once and then pass that user object in a standardized form to all of your separate web pages and stuff. There's a lot of libraries to do that in Python and other languages, but your mileage may vary on integrating it. So, yes. So I almost never use blueprints ever. The reason why is like my services are generally like 100 lines of code or less, and I feel like, why bother? Yes.
So you talked about using a CDN or caching when you're making calls into a service. Now, I will be doing my own caching talk, but I did want to ask one question that's service-oriented specifically. Have you ever tried using caches as an intermediary between the microservices? Because some folks do use that, but it can add a lot of complexity. I
do that for everything. It's sort of hard to explain it in the scope of this talk because there's not enough time, but putting a cache on the client that's making the API requests, as well as on the server which is handling the API requests, is the best bang for your buck in terms of performance. Because the only way to speed up an API request in the most effective way is to just not make it, right? So like, it's always better to just not do something, which is the answer to that question. Yes?
So actually, this was an awesome talk. I have one silly question and a good one.
Okay.
But the question I'm going to ask is in a distributed system, how do you do profiling? So I like the idea that you're saying outsource.
Mm-hmm.
But now if I want to do performance profiling across my service and things I call other tools, how to go about it?
So New Relic, it's a hosted service, newrelic.com. They are like my absolute favorite monitoring tool of all times. There's a lot of competitors which you can check out. I'm sure they're equally good. But New Relic, what it allows you to do, so you run it on your service. It's like a single line of code. And it will show you every request that was made. And you can click on the request and get a breakdown, like how much time was spent talking to the cache, how much time was spent writing to disk, how much time was spent making another API request.
So if I actually outsource some part of my system to someone else, can I actually traverse
Yes.
domains and find out how the performance was again?
I mean, you can see how long it took for them to respond to you, if that's what you're asking. But by correct, exactly. So you cannot tell what the other side is doing. Yes.
Like which fancy prototyping of which UI library would you suggest?
UI library? I'm not really much of a UI guy, to be honest. I do Bootstrap and like a little bit of Angular. So whatever you prefer, I guess. Yeah. So RQ is like one of my favorite tools right now. Basically, Celery, I've been using it for a really long time. It's super awesome. If any of you have ever used Celery, you will realize how awesome it is. The problem with Celery is that it does like everything, man. So like you can schedule cron jobs, you can specify like 10 different backend types and result stores. And to me, I feel like 99.9999% of the time, I just don't need that. And so RQ basically took the opposite approach, which is they force you to do it one way. And because of that, their docs are like, they fit in one page. There's very few configuration options. It's very simple, the code base, and really stable. So that's sort of why I prefer it. Anyone else for the end? All right, cool. Well, thank you guys again. It was a pleasure, man.